Hey everybody, Mr. P here, giving you another video on an assignment. This time it's a review assignment for a test we're having. This is on simplifying exponential and radical expressions. So we got 16 questions here. We're going to run through those, hopefully quick-ish. Hopefully you don't need too much help with them at this point because we're having a test real soon, tomorrow. But here we go. Okay, the first four problems all revolve around the first property we had learned about, that when you have like variables multiplying together, you can simply add their exponents for a simplified expression. So let me just write her down real quick. Y to the 3, y to the 5th. When you do this, you're basically just adding it all up. So 3 plus 1 plus 5. The 1 comes from the fact that if it's just a letter, it still has an exponent. It's just not written. So it counts as 1. So this will be y to the 9th. So that's what I'm going to put. Next problem. Okay, so on this one, we've got a little bit more stuff going on. We got a negative 7v, negative 2v to the 9. So first thing is they've included numbers. When you have numbers, they multiply together. So numbers multiply to numbers. So negative 7 times negative 2 is positive 14. And then these exponent rules still apply. So we're going to get v to the 10 because we add them together. So multiply the numbers, add the exponents. V to the 10. I wonder how sensitive my mic is. My kids are having a loud time back there. It's a good time, but it's kind of loud. At least I can hear it. All right, anyways, we've got negative 5y to the 4, negative 2y to the 3. So this is like the last problem. Again, numbers go with numbers. So negative 5 times negative 2 is positive 10, and then y to the 4th and y to the 3, those add together to make y to the 7. Simple stuff, I hope. 10y to the 7. Okay, the next one I did see a lot of people making a mistake on during class today, and I think the reason why is because for some reason everyone feels like there needs to be like two parts to the answer, like a v part and a y part, and each part gets its own number out front. I'm actually going to write it down and show you like what I mean by that. So what I saw a lot of people doing was this. They did 4 times 2, and they made 8, and they did v to the 9 and v, and that made v to the 10, and then they did this thing where they're like 6y to the 6. Because the 3 and the 3 make 6. But here's the problem. This isn't right. You can't have 8 and 6 like that. I saw so many people have two numbers in there. It's weird to me. You have to further multiply. You can't have 8 and 6. They have to be combined as one. 8 times 6, which is 48. V to the 10, y to the 6. So maybe when you're doing it, I mean, you can do the steps like this if that's kind of the way you're feeling it naturally. But what I would do is I would do 4 times 2 times 6 all at once. So 4 times 2 is 8, 8 times 6 is 48, and skip right to the 48 part, and then add 9 and 1 to make the v to the 10 and y to the 6. So be very careful. Your answer should contain one plain number multiplied out front. It should not contain two different numbers that are being multiplied, because I think the problem is that people are feeling like 8 is attached to some letter and 6 is attached to some letter, and they have to stay with their assigned letter. That's just not the case. All right, next one. We got the subtraction property, or it is technically the quotient property, which says you do subtraction. So sorry, that's why I call it the subtraction property. You do y to the 7 minus 5, and this gives you y to the 2. That's all you got to do. Oops. There's the exponent. All right, a complicated one. In fact, most of the division property ones are these complicated ones. Oh, they look complicated. I don't think they're that complicated. But they do include the potential for negatives to appear, and I saw that happen on plenty of assignments. I hope I get to show you one. This particular problem will not be like that. So first thing you do is you reduce. I'd get a calculator out or whatever and do 21 over 28. You have full permission to use Desmos. And if you want, 21 divided by 20, and I pushed every button but the 8. There you go, 21 divided by 28, and then hit this little button here, 3/4. So on here, I'm going to say this is 3/4. Probably extend this a little bit. Okay, now we're going to deal with these exponents. So we subtract. So 5 minus 4 and 2 minus 2. Now 5 minus 4 gives me 1. So what I get is w to the 1, essentially. But you don't need to write to the 1. Just w is fine. And x to the 2 and x to the 2 make 2 minus 2, which makes 0. And if it's 0, there's no need to write it. Like, it's unnecessary. You could write x as 0, but you don't need to do that. Now, some people get the impression that because there's division going on, the letters have to move somewhere. Like, so many people are confused and conflicted about, should the W go top? Should it go bottom? Like, what should we do, right? Think of it this way. Look at the problem to begin with. Are there more W's on top or on bottom? There's more on top, so something should end up on top. Are there more X's on top or on bottom? Well, no, it's the same, so logically it makes sense that it'll cancel out and you won't see them anywhere. Hopefully we see some with additional on bottom. Nope, not this problem. Alright, well, I'm still doing it. X to the 4th, y to the 5th, 27, x squared, y to the 3. So same deal, reduce 9 over 27. I get 1/3. I'm just going to put 3 on the bottom. You don't need to put a 1 on the top unless there's absolutely nothing left up there, so I'm not going to write the 1 yet. Okay, now we're going to do x to the 4th and x squared, which makes x to the 2, because 4 minus 2 is 2. Goes on the top. It always goes on the top. By default, goes on the top. 5 minus 3 is 2, so y to the 2 goes on top. And again, goes on the top, nowhere else, by default. Now, I didn't end up needing to do anything else on the bottom, so I'm just going to leave it as that stuff over 3. Okay, this is a pretty good one. Covers what I wanted to make sure I at least showed you one of. Sorry, that's supposed to be an x. Ooh, it's gross. Okay, it's acceptable now. 30x4, y3. So if we reduce the fraction, 24/30ths, this seems one worthy of Desmos, I guess, for your knowledge. I get 4/5. I mean, technically, they're both divisible by 6, so 24 divided by 6 is 4, and 30 divided by 6 is 5. Okay, now for the numbers. You still need to do top minus bottom. People start doing this thing where they're like, 4 minus 3 is 1, so they write x to the 1 on the top. That's not right. You got to do 3 minus 4, which is negative 1. So I'm going to write it up there. And then I got 3 and 3, and those will basically cancel out, so I don't need to write that. Now here's the deal. You can't write to the negative 1. So people do this thing where they're like, well, just write x. You can't just do that. The cost of changing the exponent from negative, what you need to do is you got to move it. So I'm going to move this to the bottom. So the 4 stays up top. Then I get 5x on the bottom. Now if you're insightful enough, you can probably notice, like I was saying earlier, there's more x on the bottom than the top. So the answer should come out with that many more x on the bottom. There's 1 extra x on the bottom than the top. So the answer should contain 1 extra x on the bottom. You can probably get away with using that logic on these division property ones. But just keep in mind, no negatives, and don't just put it top or bottom wherever. They go on the top by default. Unless it was going to be negative, then it would have needed to be on bottom. All right, new property. New property says when you have a power to a power, you multiply the powers. So you get w to the 20. There's your answer right there. W to the 20. Okay? Now, when there's multiple things inside a parenthesis, here we've got w with a 4, and they're both getting squared, everything gets squared. The 4 gets squared, and the w gets squared. So what I'm going to get is I'm going to get 4 squared, w squared. And you can't just say 4 squared. You have to find out what 4 squared is. It's 16. equals, my mistake, 16w squared. Notice the w didn't have an exponent to multiply like I did on the previous problem, so I just gave it the one that was on the outside. That's what you want to do basically. Technically you're doing 1 times 2, which is 2. At least on that problem. All right, next. BA4 squared. All right, so on this one, what's going to happen is everything gets the power. The 6, the B, the A. Sorry, those arrows kind of stunk, but here's what we're going to get. It's negative 6 squared, B squared, A to the 4th squared. Now you'll notice I put everything in a parenthesis, especially and most importantly that negative 6. I cannot tell you how many people are typing this to check what the number becomes, and this is completely and utterly wrong. If you watch me on the second one here as I put in negative 6 in a parenthesis and square it, it is positive 36. That is the difference between right and wrong. If I find out you missed the problem because you simply put a negative sign when you shouldn't have, that's wrong. Like, I'm sorry. I need you to know the difference. This is 6 squared with a minus in front of it. 6 squared is 36. The opposite of that is negative 36. This is literally negative 6 times itself twice. Negative 6 times negative 6, which is positive 36. That is very important because on problems like this, you're going to get it wrong if you do not properly input it if you're going to use a calculator. I also get b squared and a to the 8 because I'm doing 4 times 2. 36b squared a to the 8. Now, oops. So there's a little bit of a rule here, though, like if you are okay at remembering a rule, that if you have a negative number to an even power, like 2, it comes out positive. If this had been negative 6 to the 4, or 6, or 8, I would have been like, oh, I know it's positive without even knowing what it is. But when you have a negative number to an odd exponent, it comes out negative, which is, in those cases, okay if you were to misinput it on a calculator, but I would do it careful. Every time you put it in a parenthesis, you're guaranteed to not be wrong. Assuming you can, copy what you're typing, I guess. Okay, next one. So I'm going to get negative 2 to the 5th. By the way, I'm not writing the problem down over here. I hope you don't mind if I just cut right to what I'm doing. Everything to the 5th. So negative 2 to the 5th becomes negative 32. And you're like, wait, you just told me to do it in parentheses so it'd come out positive. Well, you might have heard that part, but not the part where I said even an odd exponent. See? Just put it in parentheses. You can be sure. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. There's 5 times it happens, so it flip-flops the sign a couple times, but it comes out negative. We've also got over here a to the 10 and b to the 5th. Negative 32, a to the 10, b to the 5th. All right, there goes all the exponent properties. Now we've got 4 questions about the root properties or the radical properties. People kind of seem to forgot this one. It's true. We spent a whole week doing the exponent properties, and then we had one whole day for these radical ones. They're kind of important. We will use them a little bit later. All right, 45. Can't be like that. The way you simplify this is you split it. 5 times 9 is 45, and 9 is 3 times 3. Now, if you don't split it in the exact same way I did, it wouldn't have mattered. As long as you get to the correct numbers at the base that are 5, 3, 3, because 5 times 3 times 3 makes 45. No matter which way you order it, you still get 45 if you multiply 2 3s and a 5. Now, what you're looking for is a pair. There's a pair of 3s right here. So when I write my answer, I'm going to write 3 not inside a root. The reason why we don't write it in the root is because 3 times 3 is 9, which is still technically in the root, and the square root of 9 is 3, which is now out of the root because we were taking the thing of it. The 5 is not paired up, so it'll stay inside of a root. Okay, now to deal with this. Now, what you could do is this. You could write this out 10 times. 5, 6, 7, 8, 9, 10. It's very annoying. I could circle off the pairs. 3, 4, 5. There's 5 pairs. Or, if you want to do it the quick way, how many times does 2 go into 10? Because when you're doing the square root, you're essentially evaluating how many pairs of this are there, or how many 2's are in this number. There's 5, so I'm going to write x to the 5. There wasn't any extra unused pairs, so this is it. This is the simplified version. So we're going to write 3x to the 5th root 5. Now you're probably wondering to yourself, what do we do if there's an odd exponent? Because odd numbers don't divide by 2 nicely. Oh, well, I'm glad you asked that, because that's on the very next question. Big shocker. So same deal. First we split the number. 28 is 7 times 4, and 4 is 2 times 2. Are you always going to get one pair and one non-pair? No, but it seems to be a very common, outcome. So I get a 2. I get a 7 in the inside because it wasn't used. And then x to the 5th. Now I could write it out 5 times. Whoops, that wasn't an x. And then, wait, I wrote it out 6 times. I'm a genius. Okay, that's why the 6th one came out so gross, because it didn't need to be made, obviously. All right, anyways, so there's 2. So x to the 2. Now, here's the deal. If you were to thinking to yourself, how many times does 2 go into 5? It goes in twice, right? But it has a remainder of 1. And also you can see in the picture there's a remainder of 1. So we're going to put a remainder of 1 in the radical. It was impossible even, to take it out. So 2x squared, those are things we could pair up and take out. And then a 7 and an additional x were left over that we could not take out. Okay, here comes another one, but this time we got 2 letters. You know what's kind of cheap? They gave me 28 again. I already know what 28 is going to turn into, 2 root 7. But I will show you the process. In fact, I'll switch it up. I did 4 times 7 last time. This time I will do 2 times 14. Because even if I do it that way, there's still a pair of 2's. So a 2, a 7. Okay, now let's use the logic I was talking about. How many times does 2 go into 8? 4. So I get y to the 4. How many times does 2 go into 3? Once. So I just write z. And then there's an additional one because this is an odd exponent. So an additional z stays behind. So 2y to the 4th z, 7z in the root. Gonna have to scratch my ear. Feels good, man. All right, last problem. Same thing as before. We got a 12. Thankfully, not another 28. X to the 5th, y to the 10. Okay, so we split the 12. Let's call it 6 and 2. And let's call the 6 3 and 2. And there's a pair of 2's. So I get a 2 on the exterior, 3 on the interior. For the x's, it gets divided by 2 twice with a remainder. So I'll write it like that. And y divides by it 5 times, by 2 5 times, and there is no remainder. I like how nicely spaced I made it, and it perfectly fit right after I put all the solution there. I like that. Okay, that's pretty much it. So let's recap real quick. I said this was going to be fast. It ended up being 20 minutes regardless. Maybe I just like explaining too much. Okay, so there were 4 questions about the product property, which says you add the exponents. Some contains no numbers. Some contains numbers in front of 2 different pieces. And one of them had 3 different numbers. Please make sure to multiply them all. There was then a few exponent quotient properties. So when you divide, you subtract the power. A basic one. And 3 advanced ones that may or may not include stuff on the top or bottom after all is said and done. We then had 3 problems about the power of powers. So you multiply an exponent when it's getting a new exponent. We even saw stuff that was multiple on the inside, so everything gets a power. And then we saw a couple problems where you got to be careful where a negative could or could not impact the problem, as well as multiple things getting the power. Then for the last 4, we saw simplifying roots with even exponents, odd exponents, a little bit of both exponents. We got everything up in there. That was it. That was the whole assignment. All right. Well, I hope that helps you if you're watching it, and I appreciate you watching it and helping yourself. And I will see you on the next video. Thank you so much. Have a great rest of your day doing math.